Every day, thousands of airplanes take off each hour all over the world. With that, we have to account for all the jet fuel needed to keep these flights cruising in the air. Then we have to think about all the carbon dioxide being emitted in the air. Today, I'm going to be discussing aviation biofuel and how it is changing the field of air travel. Aviation biofuel, known as SAF, is a renewable energy that is a low carbon fuel made from waste materials. The best part about this is that it functions just like the petroleum used normally in aircrafts. SAF also works in aircrafts without any engine modifications needed. The emergence of this renewable resource can help replace fossil fuels and move us toward cleaner skies. There are a variety of origins where aviation biofuel can grow from. Some of the most common and popular growth practices are derived from plants, used cooking oil, and energy crops and algae. Now let's look into how the fuel is produced. There are three main ways that this fuel is transformed into ethical and environmentally friendly energy for aircrafts. The most common practice is the hydroprocessed esters and fatty acids. Previously used oils and fats are collected. Another way can be from photosynthesis, where plants accumulate oils and then the oils are extracted and purified. Lastly, they go through hydrotreatment and cracking, where usable molecules of SAF are produced to mimic normal jet fuel range. The Fisher and Tropsch method is where agricultural residue from crops is turned into a gas and then reassembled into liquid hydrocarbons. The final method of production of aviation biofuel is where alcohol is turned into fuel. Biomass carbohydrates are broken into sugars, which are fermented by microbes into alcohol, and then aviation chemists turn that alcohol into jet fuel. Plants and algae grow due to sunlight, water, and carbon dioxide. This is the process of photosynthesis. These plants absorb high amounts of carbon from the air during photosynthesis and store it as biomass, where oxygen is also produced. Later, these plants are extracted of the biomass to turn into SAF. SAF, although not fully worldwide, is already being used today at large airports like LAX, San Francisco, Heathrow, and Amsterdam. They regularly blend SAF into their fuel supply to cut their carbon emissions by a significant amount. Airlines such as United, Delta, Emirates, and Lufthansa have completed hundreds of SAF-powered flights, proving that this fuel is efficient and environmentally friendly. But right now, SAF makes up only about 1% of global jet fuel use. In order to meet goals of improving and preventing effects of climate change, production needs to be on a higher scale. Many governments around the world are pushing for rapid expansion. In the United States, they hope to reach the threshold of 3 billion gallons of SAF by 2030. The biggest advantage of aviation biofuel is its impact in our carbon footprint. The use of SAF results in significant reduction in carbon emissions. Because plants and algae absorb high amounts of carbon dioxide as they grow, the carbon released during the flight is captured by what was captured earlier by plants and algae. SAF also produces fewer particulates, which is a big contributor to lessening aviation's global warming effect. Aviation biofuel also has economic benefits. It creates jobs in diverse fields such as agriculture, engineering, biochemistry, and construction. It can also boost rural economies. If SAF plants are built on large scale, this leads to a reduction in the dependency of imported petroleum. With economic improvements, SAF brings a lot of challenges, such as SAF currently costs 3 times more than conventional jet fuel. Aviation biofuel can be marketed to a diverse audience through social media and seasonal campaigns. During the Earth Day month, airlines can use aviation fuel to advertise how they use it and how their travel path can be better and more sustainable. Aviation biofuel is already progressing in terms of technology, but it is still behind in production due to cost and demand. Based on my analysis, expanding investment in advanced SAF pathways and increasing government incentives can increase in biorefinery scales. Companies like Shell are already getting more involved to make SAF more accessible and affordable. If cost was not an obstacle, we could accelerate progress by building large SAF biorefineries near major airports and airline headquarters. This way, those in the aviation industry could get hands on the view of the process and be more involved. Thank you for listening. These are my sources.